Today's lesson is how to do algebraic angle proofs, and this is the same philosophy as how we did algebraic segment proofs and just algebraic proofs in general, only now we're going to be using some angle vocabulary words. So as you know from before, step one is to always write down your given exactly how you see it. Now you can abbreviate some words, but for the most part, you can't make an equation. It's a copy and a paste. Angle 1 and angle 2 are a linear pair. And I did abbreviate linear pair by writing LP, but that's not changing the meaning. And remember, your first reason is given. From here, we're going to stop and ask ourselves, okay, is there any vocabulary? So angle 1 and angle 2 are a linear pair. I hope that the word linear pair jumps out to you as, hey, vocab. So linear pair is my vocabulary word. When I have that vocabulary, I need to define it. My next step is going to be the definition of linear pair. Linear pairs add up to 180. So I need to write my general equation first. Angle 1 plus angle 2 equals 180. That's what a linear pair is. From here, we want to get some numbers in our problem. So I know angle 1 is equal to 93. So I'm going to replace angle 1 with 93 plus angle 2, which is 3x plus 18. And again, that equals 180. What we just did is called substitution. Property of equality. Once you get it to this point, you solve algebra however you'd like, but everybody's proof has to start out this way. I can't jump steps. I got to have the given, I have to have my general equation, and then I have to substitute. How I do math is just up to me as a person, so I can do it however I want to. Some of you like to move the 18 individually from the 93. Some of you want to combine like terms. It's up to you. I prefer to combine like terms. 93 plus 18. If they're on the same side of the equal sign, you just do what's called combining like terms. 93 plus 18 is 111. Plus 3x equals 180. This is referred to as CLT, combine like terms. The next thing I'm going to do is go ahead and solve it. I'm going to do this in pencil because we want to make sure our proof is in like a perfect order. So I don't really show any side work. Now your underline for combining is fine, but when I'm actually doing a property of equality, remember, I'm going to subtract the 111 to the other side, but I need to erase my side work at the end. So for right now, I'm going to do it, and then I'm going to cross it out and erase it at the end. So I bring down my 3x. 180 minus 111 is 69. And the property I did was subtraction. Notice how we subtracted on both sides. Subtraction, property of equality. This is the step you subtract. Next, we want to get x by itself, so I'm going to divide both sides by 3. The 3 cancels here and here. 3x divided by 3 is just x. 69 divided by 3 is 23. And we divided by 3. So my reason is division, property of equality. If you're unsure if you're doing these proofs right, you can always check your work. The good thing about a proof is it tells you the right answer. X has to be 23. Well, we got x to be 23, so we know we did it right. So our final piece here is just I'm going to go back and just clean up my side work, get rid of anything that we don't need in our problem. All right, let's try one more. And remember, there's different vocabulary words, but the math is pretty much the same as long as you know your vocab. So let's start with this one. Given angle 1 and 2 are vertical angles, prove x is 14. Step 1 never ever changes. Write the given. The reason is given. That part never changes. It's just you copying and pasting that information in your proof. Angle 1 and angle 2 are vertical angles. And again, I'm abbreviating, but I'm not changing the meaning. Once I have my given written exactly how I see it, now I'm going to go ahead and write my general equation. Vertical angles are congruent to each other, so we're going to go ahead and say angle 1 is congruent to angle 2. This is the definition of vertical angles. Definition of vertical angles. I see vocabulary words. I define vocabulary words. Now this is the step everybody forgets. I can't jump into numbers and substituting right now. I have to make it equal. So the measure of angle 1 equals the measure of angle 2, and that's called the definition of congruency. Once it's in terms of equals, now we can substitute. So angle 1 is 98 equals angle 2, which is 7x. That's called substitution, property of equality. Everybody's proof has to start like this. There's no way around it. How you do your algebra is up to you. So I'm going to go ahead and divide both sides by 7 because we want to isolate our x value. 98 divided by 7 is 14 equals x. Division, property of equality. But we're not done. It says prove x equals 14, not 14 equals x. So this is where symmetric property comes into play. Remember, symmetric property of equality isn't used every single time. It's only used for when you need it. So if I had solved it differently, I wouldn't have needed symmetric property. It's just there for you to flip your equation around so the proof matches the proof.